All right. Hello, everyone. Today we're looking at radical equations and how to go about solving them. So let's start with this equation, square root of 3x minus 1, all inside the square root, plus 8 equals 10. Right, your first step with any one of these radical equations, if you can, let's try to isolate the radical. So in our instance, we have a 8 that we're adding to the radical square root. Let's subtract it from both sides. And you get the square root of 3x minus 1 equals 2. All right. Next step would be to square both sides, but except one case. Let's get to that case right now. If you had a radical square root equaling a negative number, then that's where you stop. Square root cannot equal a negative number. In fact, anything that's even, that will not work out. So if you have the square root, the fourth root, etc., not going to work. If it was an odd number, no problem. So it was like the cube root or the fifth root or something, equals like whatever, negative 4. Yeah, that's fine. As long if it's odd, fine. But if it's even, no solution. Okay. All right. So in our case, what we're gonna do is, sorry, let me square both sides. And we do this essentially to get rid of the radical, because a square root and a square just goes away, and 3x minus 1 equals 4. And we'll go ahead and solve the remaining equation. So I'm going to add 1 to both sides. And you get 3x equals to 5, so x equals 5/3. So when you get to step 3, you'll get to something that, an equation that you recognize and you'll be able to solve. So in this case, it's a linear equation. In other cases, it could be a quadratic. So something of the sort. Now, step 4, if you want to call it a step, is to check your solution if you can. Okay. So the solutions that you get, sometimes you'll get multiple solutions. Not all of them will work in the original. Okay. So I'm going to go back to the original equation, which was 3 times 5/3 minus 1 plus 8. And I'm going to check to see if I get 10, and I have a question mark here. So here inside the radical, the 3 and the 5/3, the 5 is what you have left. The 3's cancel, 5 minus 1. And 5 minus 1 is 4. The square root of 4 is 2 plus 8 will give us 10. So our solution is x equals 5/3. All right. Now let me go through another example here. So step 1 with this equation would be to isolate the radical. So that square root of x minus 5, we want it to be alone. So I'm going to go ahead and subtract 9 from both sides. Subtract 9. So to get root x minus 5 equals x minus 7. And here I'm going to go straight to step 2, which is squaring both sides of the equation. Since you have an x minus 7 on the other side, and that's just just a single number, then the whole talk that I gave about making sure that the other side equals a positive number on the side of the radical, that doesn't apply here. So yeah, if you get variables on the other side of the radical, just go ahead and square both sides. And this cancels. This is x minus 5. And this step, you need to be careful, because people make a big mistake and they'll say the solution to x minus 7 squared is x squared plus minus 7 squared, and that's it. That is not the case. You're squaring a binomial. So a couple ways of doing that. One way is to apply the formula a minus b squared equals a squared minus 2ab plus b squared. So in our case, the a would be like it's x, so it's going to be x squared minus 2 times x, and b is 7 plus 7 squared. Okay. Now, if you don't like that, you could FOIL that out. You could first of all write x minus 7 as x minus 7 times x minus 7, and then FOIL that out, etc. That's another way to do it. However, I'd recommend you have that formula, the a squared minus 2ab plus b squared handy. It's just pretty useful. There's also a plus b squared, which the only difference is that there's a plus in the middle. Okay, so having those formulas, knowing them, can save you some time instead of like boiling things out. All right, so I'm gonna simplify what I have here. That 2x times 7, that's 14x. 7 squared is 49. And I'm gonna move everything over to one side because this is a quadratic equation, and 2 is just easier to work it that way. So I'm gonna subtract x, give me minus 15x, and then I'm gonna add 5 to both sides, which is a 54. So we have 0 equals x squared minus 15x plus 54, and that will factor out as, well, let's see, does it factor? Yes, I believe so. X minus 9, x minus 6. So we're going to use the zero product property, which says, yeah, if you have a bunch of things equal to 0, and you're multiplying them, each one is equal to 0 individually, so you get 9 or 6. And now step 4 to check our solutions. Let's go back to our original equation. Let me just write it down here for reference. Square root of x minus 5 plus 9 equals x plus 2. So checking our solution, let's start with 9. 9 minus 5 plus 9. Square root of 9 minus 5 plus 9 equals 9 plus 2. 9 minus 5 is 4. 2 plus 9 is what we get here, equals 9 plus 2, so it checks out. And then we're going to go ahead and work with 6. Square root of 6 minus 5 plus 9 equals 6 plus 2. 6 minus 5 is 1. 1 plus 9 is 10. 6 plus 2 is 8. This does not work, and that's what I was getting at. One of your solutions might not work out. So x equals 9 is our only solution here. Okay. All right, and that does it for that. Now, there are, I'll just give you a little warning, there are other instances where you're isolating the radical will not be as easily as we did here. It might take you a couple steps to do that. An example of that is something along the lines of square root of x minus 5 plus square root of x plus 1 equals 4. Yeah, I can't isolate the radical here because there's two radicals. So the best thing to do, in my opinion, is to take one of the radicals in this instance and put them on the other side. And how do we get rid of radicals? We square them. So we can begin by squaring that radical, and you get rid of that one, x minus 5. And if you just believe me here on the math, it would look something like what I'm writing down. And what you could do is you can then move the 16 over and move all of the x and the plus 1 all over to one side. Isolate this out, and you would get something along the lines of minus 8 root x plus 1 equals, let's see, minus 22, something along the lines of that. And that would be what you would go ahead and, square both sides. Okay, now you could do that. And yeah, on the other side of the radical isn't isolated here. It was like a divide by 8 here, negative 8. And yeah, you can still go ahead and try to solve this. Okay, so just to let you know, that can happen where you might have to move a radical and square more than once in order for you to just get rid of all the radicals in here. Okay, all right, well, thank you for your time.